Now in the previous video we studied about the electric field energy, the field energy of electrostatic field, which was the work done in creating that, the work done by that electric field, that external electric field on any charged body. Now in this section we'll study about the self energy. Now as the name suggests, the self energy is acquired by the body itself. So let us say that we have a metallic sphere of radius r, center is at C, and let the charge, or let the initial charge on this sphere be equal to 0. Now let us say that we brought some charge q on the sphere. Now when this dq, a small elemental charge, is brought from infinity to the surface of the sphere, dq will face repulsion from the already existing charge q. So that means we have to do some work in bringing this dq from infinity to the surface. Now let us say that bringing all the dq's from infinity to surface, we do a total work done dw equals to dq into v, where v is the potential of the surface, which is given as kq upon r, which is where q is the already existing charge on the surface of the sphere. So the total work done, so the small work done in bringing dq will be given as dw equals to dq into v. Substituting the value of v here, we get dq equals to kq upon r into dq. Now that if all the dq's are brought, then the total work done can be found out by integrating this expression. Now let us say that the initial condition was when there was no charge, and after some time, when all the charges are brought to the body, then the total charge on the surface is equal to capital Q. So that means we are bringing dq from 0 to capital Q. So these will be our limits, and if we calculate it, then the work done will be equal to kq square upon 2r. Now when the charge q is brought and accumulated on the surface, then this surface will have some electric field. Now this electric field will extend, let us say, from the surface to the infinity. We are not giving any higher limit as of now. We are assuming that the electric field extends to the infinity. So the electric field, to understand this electric field, let us assume a hypothetical shell of thickness, small thickness dx around this sphere. Let the radius of this shell be equal to x. Now the volume of this shell, if it has thickness dx, will be given as dv equals to the surface area of the shell into thickness. So this will be equal to 4 pi x square into dx. Now electric field, as we know that E equals to kq upon x square, then du, that is the energy, small energy, will be equal to half epsilon naught E square dv. Now putting this value of dv from here, we get this expression kq square upon 2x square into dx. Now to calculate the total energy of this system, we integrate it. Now where are we integrating it from? We know that the electric field does not start from the center of the conductor, it starts from the surface of the conductor. So that means the starting limit of the electric field will be r. So we have taken r here, and since the electric field is extending to infinity, so our limits will be from r to infinity. Now if we integrate this, we'll take the constants outside and we'll integrate, so we'll get the expression kq square upon this will be 2, no, I'll write it here, u will be equal to kq square upon 2r. Now this energy does not have any source outside the body, it is the energy of the body itself. So we can say that this body, this energy is called self energy, because it is the energy of the body itself. So once a body is charged in this way, its self energy is considered as a constant because it has already been charged to the maximum capacity. So this will be the maximum energy, that maximum self energy the body can have. So if we have to define, we have to give definition of self energy, then we can say that self energy of a charged body is the total field energy associated with the electric field due to this body in its surrounding, and it is same as the work done in charging the body in the given final charge configuration and shape. So this can be the definition of self energy, and this will be the very important expression of the energy because of this work.